Well, welcome to 3.3. We are going to look at volume and capacity of different three-dimensional figures. And these are things that you deal with every day. If you talk about the amount of liquid in your Red Bull, or how much ketchup you get in when you buy a bottle of ketchup, or how much you're going to pay for gas, all these things are amounts that end up in a container. And the containers that we're going to deal with today are prisms and cylinders. So in this case that we're looking at now, these are different fish tanks. And you know that as you look at these, the one in the far left, tank number 1, clearly holds more water than tank number 2, which clearly holds more water than tank number 3. But how do we compare them in terms of the amount of water? Well, we would need to figure out the volume. And volume would be length times width times height. Now when you figure those out, you're going to get different values, with the largest value being tank 1, and then tank 2 less, and tank 3 even less. And you'll notice that when you compare these values, the only value that's different amongst these tanks are the one length. Everything else is 20, 20, and 20. So what's the impact of decreasing that length by 20 centimeters? How does that affect the total volume? And do we talk about volume in terms of centimeters cubed, or do we usually talk about milliliters or liters or even cubic centimeters? And how does that apply in this case? You're definitely going to have to explore that as you do your assignment. We also deal with some cylinders. This example here is talking about the grips that you have on a rock wall. And you can see here that this grip is going to be cylindrical, and that it's made by a machine that pours plastic into a mold, and then it hardens. And this is the size of the mold. It's 3 inches, and then it has a radius of 1.5 inches. To find that volume, you would need the radius, which we're given as being 1.5, and we would plug it into there. And we need the height, which we're given, which is in inches, and we would multiply it together, and we would get an answer in cubic inches. Can we convert that to centimeters cubed or cubic centimeters? That's going to be a challenge that we're going to have to face. You also have some questions where they have a relationship involved, and this is with regards to the engine displacement of a vehicle, or it's related to the power of the vehicle. The higher the displacement, the more energy the vehicle can exhibit. And what it's related to is the size of the bore of the cylinder. So on this page there are 2 cylinders. It's basically the size of the hole. The piston goes up and down inside that cylinder, and the size of that bore is the size of the hole. And the distance that the cylinder goes up and down will determine the stroke. Also, we have the number of cylinders, and the more cylinders there are, the more engine displacement there will be, or the more power and energy the engine has. So in this case, we're given a stroke of 82 millimeters and a bore of 75.55 millimeters, and we have 4 cylinders. So that's the number that would go in the pink, and we would multiply them all together, and we would get an answer in millimeters, and the millimeters would be cubed. And we don't usually talk about engines in millimeters cubed. As it says here, often we'll talk about a 5-liter engine or a 4.7-liter engine, and that determines your displacement. Sometimes cubic inches come into play, particularly in the United States. And how do we relate that to cubic centimeters or liters or milliliters? And these are some of the things that you're going to have to look at as you do this assignment. It's important that you ask questions when you have them. Don't leave well enough alone. If you don't completely understand, please ask your teacher. I would be glad to help you better understand this material. So that's the basics. Now you got to sort out the details on your own time. That's it. And we're